Okay, so now let's look at a couple questions. So first is to find the equation for the tangent plane to this surface, z equals x cosine y minus y e to the power of x at the point 0, 0, 0. Okay. So to figure out the tangent plane to the surface at a given point, the core idea is the gradient of the function x, y, and z evaluate at this point. Actually, it is normal to that surface. So with that, we actually can drive that the gradient, the dot product, the if you denote the function, the vector as x minus x0, y minus y0, z minus z0, it will give us a 0. So that's how do we compute the equation of the tangent line at a given point for a surface. Okay, but for the surface in this notation, which is z equals f of x and y. So z equals f of x and y here. So the plane tangent to this surface at a given point you're going to have is partial f. And then, of course, evaluate at the point times x minus x0 plus partial y, y minus y0. And then it's minus, actually z minus z0 equals 0. Y here is -1 because, if you reorganize this function into, x cosine y minus y e x and then minus z. So if you denoted this is a function in terms of f of x, y, and z here, and then you can see that the gradient is going to be partial f, partial x, partial f, partial y, and then partial f, partial z. But for the partial f, partial z, the z, that component actually equals -1. So that's why directly here is -1 here. So if you understand this, then all the rest of the pieces, it is super straightforward. So what we can do is we can figure out the partial derivatives. So it's a partial f partial. Suppose we set this z equals f of x and y. So partial f partial x evaluated at the point 0, 0. Is going to be, so this is going to be cosine y, right? Minus y times e to the power of x. And then we do the evaluation at 0, 0. So it turns out this is going to be cosine 0 is 1. And then minus 0 give us is 1. And then f partial y evaluated at 0, 0, which is x times negative sine of y, right? And then minus e to the power of x. And then, so if you evaluate at the point of 0, 0, noticing that, so this is going to be 0. This is going to be e to the power of 0, which is 1. So it's going to be 0 minus 1, which is -1, right? So yeah, so with this, and then we can easily to figure out the equation for the tangent plane, which is 1 times x minus 0 plus -1 times y minus 0 minus z minus 0, right? And it turns out, as you can see that what you get is x minus y minus z equals 0. So that is the equation for the tangent plane. So it's a super simple. Okay. So the next question actually is associated with number 1. So it's find the parametric equations for the normal line to the surface at this given point. So you can see that the gradient for this, actually we already calculated, it's a 1, -1, and -1 here. So the normal line, what we can drive here is it's going to be x equals 1 times t plus 0, right? Y of t, well, let's write it into this. It's going to be -1 times t plus 0. And then z of t is going to be -1 times t also plus 0. So it turns out the normal line, if we write it into the component vector notation, that's going to be t, -t, and -t. Okay. So yeah. So that's how do we drive this. So you can write either in this way or in this way. Okay. Either way will work. So that's this problem. And the next problem here is okay. So if it asks us find the parametric equations for the tangent line to the curve of the intersection of the surface, and then this is surface, this is surface, those two, they have some intersection, and between that curve they intersect, there's also a point. So this problem asks us, okay, to figure out the equation of the tangent lines. Okay, so let's see, how do we handle that? Well, it turns out that still you need to do some evaluation for the gradient. So both of them actually are related with the gradient. Okay, with the gradient. So let's take a look at it here. So the gradient. Let's see. So let's have the partial f and then partial x. For this situation, it will give us, so if we denoted this is the function f, and I denoted my f as let's see. So give me 1 second, guys. So 1, 1, 3. One second, okay?